series is n square. How we can do this? We know that n plus 1 cube, that means we take 1 power exceeding. This is equal to n3, 3n square plus 3n plus one more term will come, 3n plus 1, right? N square, n cube, n square, n 1. Now I open this using binomial. Therefore, now how we can do it? I take this on left side, n plus 1 cube minus n cube equal to 3n square plus 3n plus 1. Now put n is equal to 1, n is equal to 2, and so on. N is equal to n. What I get? If I place 1, that is 2 cube minus 1 cube is equal to 3 into 1 square plus 3 into 1 plus 1. And when I put 2, then it becomes 3 square minus, this is 3 cube, 2 cube is equal to 3 minus 2 square plus 3 into 2 plus 1, and in last when I place n, then it is the same, that means n plus 1 cube minus n cube is equal to 3n square plus 3n plus 1. On adding this term, I see this will cancel with this will cancel with this, and this will cancel. So on adding, what I get? I get n plus 1 cube minus 1 cube is equal to 3 into sigma, or simply I keep this 1 square plus 2 square n square, and this I get 3 into 1 plus 2 plus n, and the last term is 1 plus 1, that means I directly write here last term is n, because 1 plus 1 plus up to n time it becomes n, because 1 plus 1 plus 1 up to n times is equal to n. So this term becomes n. Now what we get? We get, this is, we have to calculate this value, this we know, this we know. So I write this 3 into sigma n square, this I take, equal to n plus 1 cube minus 1 cube, and because this term I take this side, so minus 3 into sigma n and minus n. This n also went on left side, so it become. Now I open this. This is n cube plus 3n square plus 3n plus 1 minus 1 cube is 1, and this is, we know, 3 into n plus 1 by 2 and minus n. Because this sum we know, already we have calculated, so this I place here. Now, more simplification give n cube plus 3, this will cancel, and this n, I can make here 2n plus 2n, so this also go. Now this become minus 3n square minus 3n, or here 2 is in the denominator. So I have to take LCM. I take LCM of 2. So to simplify it, what happen? This become 2n cube plus 6n square plus 4n minus 3n square minus 3n divided by 2, right? Now this 3n square, and here is the 6n square, so I have 2n cube plus 3n square, and this give n, and 2 is in division, right? Now n can be taken common, n is out, so it remains 2n square plus 3n plus 1 divided by 2. Now what is this? This is equal to, this I can write n into 2n square plus 2n plus n plus 1, and 2 is in denominator. So these the factors. Here 2n I can take common, so I rub this part. Okay, so this become 3 sigma n square, left side is n square, and this become n by 2 is out, and from here I take 2n out, so I have n plus 1, and the last term is n plus 1. So again n plus 1 can be taken common, so this become n by 2 is out, n plus 1 again out, and inside remain 2n plus 1. So this is the final. Now this 3 I divide both sides. Sigma n square is equal to n by 6 into n plus 1 into 2n plus 1. So this is the sum of the first. Now similarly, if I want to calculate the, if I take n varies 1 to n, that means the first n term, actually I have to change. This is formula for the partial sum. Partial sum is n by 2 into n plus 1 into 2n plus 1. But if I take n varies 1 to infinity, then what happens? I have to apply the limit. If I change this, then I have to take limit n approach to infinity. Right side also I take limit, so whole term become infinity. So for infinite it become infinite, and for first n term it become this. That means what is the final result? The partial sum of first n terms is n into n plus 1, 2n plus 1 divided by 6. Sorry, this is 6. This is 6. And sigma n varies 1 to infinity, n square is equal to infinity. Similarly, so this is the result. Similarly, if I want to find the partial sum of sigma n cube, I do the same. I take first 1 power extra. That means this I will expand binomial using binomial, and I follow the same process. So some partial sum of n cube can be found.